Show you a few things just to entertain you a bit. This is an antenna switch. If you have multiple antennas, you want an antenna switch. Okay. Positions 1, 2, then ground, 3, 4. And what it does, it has a gas capsule in it here, and if there's a static discharge off your antenna, then it'll blow this capsule out and not blow your radio apart. Okay, so that's a handy piece of equipment to have. Otherwise, if you don't have an antenna switch, then you have coaxial ends of your cable, so you would be taking these off and on of the back of your radio. Now most radios have at least 2 antenna connectors, and you have an internal switch inside, so most people don't have more than 2. So nowadays the use of an antenna switch, and really unless you've got a lot of antennas, you really don't need this, because you will have an antenna switch in your right built into your rig. Okay, and you see these, of course, would be carrying the cable, and they should go in there, but it's not. Okay, don't ask me why. If lightning strikes your antenna, forget it. It's going to blow it up. There's not a darn thing you can do about it. Okay, but you're better, remember that pole? You're better to have that metal pole all the way down to the ground, because hopefully it'll follow that path to the ground. But a lightning strike is not what's going to happen. What's going to happen, there's going to be lightning in the area, and you're going to get a static discharge. And the static discharge will blow your radio out. Okay? So that's why you need that gas cartridge in there, or you buy these. And what you do here is a gas cartridge in here, and this will take, I believe this will go even up into UHF, VHF frequencies. Okay, so this, you connect that to ground. This is the in, that's the out, and away you go.
So it's like a fuse?
It's like a fuse, yes. It'll blow and stop the power from getting into your radio. Yes?
Is that rated in joules or watts?
I'd have to look that up. It doesn't take very much.
Okay.
It takes almost nothing, and it'll blow it. A static discharge.
Okay.
And that's what usually ruins your radio. Yes? Question?
Did you put that inside the house or outside the house?
Yeah, now, in the instructions, it says put this closest as possible to the radio. But I've seen these in a box outside the house, in a little box sealed. I've seen them inside the house, like down in the basement, and the other cable going up. So, it's going to work regardless. Okay, so that just gives you some idea, some of the things we've got here. And we've got a whole bunch of connectors. I could pass all of this stuff around. You should probably play with it. See, now there's another way of doing it. Here we have a connector, right? This would go in your line, and it's giving you a ground connection to make sure that it's grounded. That's what that's for. If you want to put 2 pieces of cable together, you want to connect 2 pieces of cable, barrel connector. One goes in there, and the other side of the cable, well, there's one in here already. But that's okay for inside the house, right? As we were talking last time. See? So there your cable is together. Inside the house. If you were going to leave this outside the house, then what we want is you're going to get that flexible rubber goo tape that Radio World sells. It's like the stuff they use for mounting windows. It's like a rubber, and it seals, and you would take that and wrap it totally around that connector if it's outside. because this is not waterproof, and it will leak, and the water will get into the coax, and it's finished. Yes, Dwayne.
So basically, the whole purpose of these little devices is kind of like a release valve.
Of this device, yes, this device, and that device is if it gets a static charge, it'll blow the gas.
And once it blows, that's it.
That's it. Then you have to replace it. These are replaceable. You just take this cap off and you can order a new one. That's replaceable too. And these are just a way of connecting your coax to your equipment. That's all these are. Now, you'll see there's a problem here. You see this? You see there's the proper, what would you call it? Strain relief in there. Adapter, some people call these. This one, see it's missing? That's what it looks like. See? And that should have been in there before the cable went in. Okay, why do you want that? Well, because this, especially if it's outside, and even inside, this is going to be doing this, right? It's going to be moving around. You want to limit, this is called strain relief. You want to limit that movement as much as possible, because the more it moves, it's going to break it inside. Okay, so that's the adapter. And you'll see there's 3 or 4 of these. There's all different sizes of these adapters. You can see the holes are different. The size of the holes are different. Okay, and you have to get the right one for the right cable. Now these are B and C connectors, and these are a beauty, because you see, bingity bang, bingity boom, it's together, right? It's apart. You don't have to thread the thing on, and so that works nice. A B and C connector. This I believe, not sure, that'll go into the Bofang, that adapter right there. I got it for a really nice price, but I think they want $10-15 for them if you buy them online. Okay, so here's another. This is your PL52 to a BNC. So there's all different kinds of connectors. Take a look at them, play with them, whatever, because you will be needing this stuff. Definitely, you will be needing this stuff when you could pass one of these around too. Okay, we were at the trap dipole antenna.
Excuse me.
Yes.
We're leaving, but one of the guys from downstairs is working on the other side.
Oh.
So he said he'll probably be here till about 9:15.
Oh.
So just so that you know, I'm still going to turn the lights off
Okay.
downstairs, just so that everything looks like the shop is closed and the front door is locked.
Okay.
So you can just leave and then he'll set the alarm.
Okay. Very good. We should be out by 9:15.
Okay, I told him to check with you before he left.
Okay.
Okay.
Very good. Thanks so much, dear.
Okay.
Okay. I'm going to show you a type of antenna as we get along here that you really don't need to do this, but just in case, you know, you're talking to amateurs or there's something on the test. This is a trap dipole antenna. So what you do is you put a coil and a capacitor here, and this has to be the same length, a coil and a capacitor here. Okay, and then there's your insulator, there's your feed line. So what you do is, this is one antenna here. Let's say this will work on 40 meters. So I don't know what you have, 33 feet here, 33 feet here. Okay, so you tune this trap here so that it creates high impedance at that resonant frequency. Essentially what's happening, this part of the antenna is cut off. You've got high impedance there, the radio wave is not going to get through. It's only going to stay in here. So it'll work on 40 meters. But then when you go to 80 meters, it passes it, and you're using the whole length, and it's an 80 meter antenna then. But it changes the length, these lengths change. They're not the same as the lengths that are used for a regular 80 or 40. They change. Okay, so if you're going to build one of these, you definitely need a somebody to tell you what the correct lengths are. Otherwise, you're going to be fooling around with getting these. But as I say, the trapped dipole is not used that much these days because of another type of antenna, which I'll go through for you. Okay, the folded dipole antenna. Now, we use this one a lot. The folded dipole, and what you need to know about the folded dipole is that it's a full wavelength. So here's your antenna, and it is like that. You will actually see those antennas for 2 meters. You'll see them on towers, but facing that way, right? And that's what it looks like. And this whole length here, all the way around, is one wavelength. And you get 300 ohms here. That's what you need to know, that it's a one wavelength, and it will give you 300 ohms. And it works very well, and it is also directional. Okay, the vertical antenna. Brent went through this the other night. The vertical antenna is usually a quarter wave antenna, right? It's a quarter wave. It's a half of a dipole. Okay, the question is, where's the other half coming from? Anybody remember? Where's the other half of the antenna coming from? You only got half of it. Okay, the other half of the antenna is coming from the ground. The ground is making up the other half of the antenna. Also, if you put a quarter wave on your car, the metal on your car is making up the other half of the antenna. The body of the car is making up, you know, one of those mag mounts antennas? The body of the car is making up the other part of the antenna. Okay, but this you can't put that on the ground, right? Because if you did, you short it out. So if it's going to be on the ground, it has to be insulated somehow. It has to be insulated from the ground. Okay. Now, if you put it on a building, put it on the side of the building, and you've seen some of them, they will have things like this sticking out, you know, and then this will be mounted somehow to the building. You'll take your coax. These are radials, or counterpoise, some people call them. Okay, that's providing your other half of the antenna. You'll see that a lot of CB antennas are built like that. Okay. Okay, but if you're using it for HF, usually what the amateurs do, they separate it from ground somehow, so it's not on the ground. But then in the ground, they put radial wires. They put radial wires, all kinds of them, in the ground. And that's to replace the other part of the antenna that's missing. Now, the thing about the vertical antenna, as we said before, low angle of radiation. It's isotropic, like a light bulb. It sends it in all directions, but it's got that low lobe. Well, I don't know how to draw the radiation pattern, but it's got a low angle here of radiation, which gets you the DX a lot better. But it has a disadvantage, and the disadvantage is noise is vertically polarized. So, you know, you flick a light switch and you can hear it on the radio. If you flick a light switch, because it's arcing, right? And it'll actually make sound on your radio. All that sound is vertically polarized. If this is vertically polarized, it picks up the noise better, right? A dipole is better because a dipole is horizontally polarized, and the noise, so it tends to avoid the noise. So it has all antennas. They have advantages and disadvantages, but as a DX antenna, it's really good. And a lot of the modern radios have such great noise filtering, right, that you can sort of take it out, so it's not a problem. Okay, now the Yagi antenna. Yagi. Well, since we have a Yagi, we're going to show you a Yagi. This is a Yagi. And you can make this antenna yourself. This is a 2-meter beam. Oh, he's got a tape there. He doesn't want me to take it off. This is a 2-meter antenna. And you will notice that it has this, it has a choke in it. Do you remember the reason for a choke? Okay. The reason you wind this little choke is because it's possible sometimes that the radio frequency energy could get onto the ground, onto the shield, and that will cause problems at your radio transmitter if you've got RF on the ground. Okay, so what you do is you put this little choke in, and it prevents RF from getting on the ground. It's not a balun. It's not a balun, it's a choke. It's just a coil that presents high impedance, right, to the RF that wants to get back on the ground. So that's what that is. This thing is a matching stub, and that's put in there to get the impedance to 50 ohms. How you calculate that, don't ask me. I don't know, but you probably have to fool around with that to get it to be 50 ohms. Okay, so I'm going to give you here. I'm going to give you the instructions on how to make one of these. But what you have to know for the test is there's 3 parts to the Yagi, and there's a driven element, and the driven element, of course, is where the coax is connected, and that's in the center. Then there is the reflector element. This is the reflector, and then there's the radiator. Did I get that right? Driven element, reflector, and director. Okay, they're calling this one the director, and this one the reflector. Okay, what is this like? Okay. Okay, it's only, you know, rods, elements sticking out this way. But this is like this. It's like a mirror. This one here, this reflector, acts as a mirror. Here's the power on this one. So the energy is going here, and it's going to be pushed forward, and then this one is going to tighten up the energy that's coming forward. So it's going to turn it into a beam. So you've got the driven here, it hits the reflector, it comes back. Well, if this was a parabola, you've seen it with probably, that's not a very good parabola. Parabola is more like that. Okay, and the energy comes here, bounces, and then goes out, or here, bounces, and it takes it into a beam that goes in one direction. That's what this is doing. It's making a beam and sending the energy in one direction. When you look at the Yagi from the top, the radiation pattern looks just like the one I showed you before. It looks like this. So all the energy is going that way, and very little out the back end, and very little off the sides. Okay, this is called these elements are called parasitic. This is a driven element. These elements are parasitic because they are not connected. In no way are they connected to the coax, as you could see. Okay, they get their power from this one, through the air. They have to be at exactly the right distance, okay, to do it. They're parasitic elements, these two. Well, this is the driven element.
Get to the right distance by measurement or by trial and error?
Measurement. You have to get instructions. Like I've got instructions here. It'll tell you exactly where to put them. Okay, so the advantage of this is directional now. So I'm pointing it this way. The power is going that way. So most of the time you have to have a rotor on this, right? If you were operating a station, you have a rotor, you're turning it. So you find out the station's in China, you find out what the bearing is, right? And the bearing is 270 degrees. You move that 270 degrees. All the power that you got is going 270 degrees. Yes?
It's very similar to what they use when they put tracking in animals and stuff.
Yes.
They're very directional for when
Yeah,
they try to find
you can use this to triangulate. Yes, you can. Now the other advantage is, since the power is going this way, what's happening on the side? Nothing. So you see, if there was an interfering signal from here, you're not going to hear it. You're only going to hear where this is going. So it's a great advantage to a Yagi antenna. It's named after a Japanese fellow, by the way.
Hey, Bruce.
Yes.
See, everybody, that's what can be used to contact the space station. Is right there with a little handheld there. Hook
Yeah.
up to it. That's what you use.
That's right. You could use this. Now, we had a discussion of that before, Jason. If you're going to pick it up on the horizon, then there's going to be Doppler effect. Okay? And the Doppler effect is, you know, when a car goes by, it goes what? It goes high frequency first because the energy is piling up, right? It goes, right? That's the way it goes. So it's high frequency and low frequency. It's the same with radio. So when it's over there, when that satellite is over there, the frequency is higher. And when it's over there, the frequency is lower. Now, there are computer programs to adjust this when you work satellite. Some people want to work satellite. You have to adjust it for Doppler effect. But, as Brent was saying the other night, if you work it overhead, right, then the Doppler effect is minimal. You work it straight up. That's what he was doing. Okay, he's working it straight over. Actually, he was using a J-pole straight over. He wasn't using a beam. But people have connected this to the Bofang, and they know that thing is coming, and they're farting with their radio to get the frequency right? And they're tracking it through the sky, you know, and they're talking to the International Space Station. This is all you need for that. Now, it's also possible to stack these. Peter, who's going to be teaching you next week, if you put two of them on top of each other, right, at the correct distance, of course, you get more gain. And if you're going to do moon bounce, that's exactly what you need. You would need a 2 meter Yagi, and you would stack it and have rotation so that you would be able to bounce the signal off the moon.
You can actually bounce the signal off?
Yeah, bounce it. Yeah, unbelievable. From what?
From a house.
Oh, yeah.
With a lot of power.
Yeah, you need a lot of power. You need an amplifier, and most of the time it's using CW most of the time. And you have to have a schedule, or schedule as they say here. That means you and I would agree that we would start doing it at midnight, right? And you agree that I will call first. And so for every 2 minutes, I call. Then the next 2 minutes, you call.
Because of the time delay.
6 seconds.
6 seconds?
6 seconds there, 6 seconds back.
Yeah. And so once I hear you and you hear me, I send my call, you send your call back, that's it. We made contact via the moon. Yeah. Now, I'd like to try it off of Mars, but I probably need a lot of power to do that. So it's, now remember I said last time, there was that K1JT, the Radio Amateur. He used Arecibo to bounce it off the moon. And so other people were talking to him, right? And they were all bouncing off the moon, and he was picking it up with that big dish. And where is it? Ecuador or Panama? I don't know where that thing is. Okay, so getting back here, the beam, yes. Because this is giving you, it's taking the signal and it's doing that to it, this is giving you 10 decibels of gain. Some of them will give you 18 decibels of gain. They give you all kinds of gain. Remember, it's in one direction, and it's great. And it's actually better to use a proper antenna than it is to buy yourself a linear amplifier, like 1,500 watt amplifier. Yeah, that's nice that people want it. You got to plug it into 220, takes all kinds of power, and it will get into your neighbor's TV, telephone, everything, piece of electronic equipment you've got next door. It's going to get into it because it's pushing out so much power, right? This is only directing the power. It's not amplifying it. And so you can get an 18 decibel, divide 18 by 3. What's that? Six times. You're getting 6 times the power just by the antenna, and you're not adding anything in terms of electronics. Okay, so it's better to use a beam than it is to buy an amplifier. Okay, but of course they're expensive too because you got to have a tower and whatnot. Okay, so I think we went through all of that. Now, we want to talk next about SWR. Okay, did we cover that? Okay. Oh, we didn't talk about the dummy load. There's the dummy load. Now, one of the radio amateurs said a very rude thing, at least I thought it was rude, called his girlfriend the dummy load. So I sort of thought that was kind of funny. But anyway, what this is not an antenna at all, but it will take the power of your radio transmitter, and it was used in the old days for testing and for tuning. When you had tubes, you needed one of these to tune the final of the transmitter. They're hardly used at all today, but they are mentioned on the test. That's why one of these things is here. And you see it'll take 1.5 kilowatts, HF to UHF dummy load. Okay, so that's a dummy load. Actually, if you put that up on a pole and connected a cable to it, it would probably won't make contacts with it. Okay, standing wave ratio. This is the next thing we need to talk about. SWR. It is a measurement. It's actually a measurement of voltages. Sometimes it's called VSWR, voltage standing wave ratio. It's indicating the effectiveness of the power transfer between the transmitter, the transmission line, and the antenna. It's telling you whether the thing is working or not. Okay? If the antenna is resonant and the transmission line impedance is matched, you will get a 1-to-1 ratio on the frequency that your antenna was cut for. And you're going to get maximum power transfer with the 1-to-1. Okay? The power is going to be going into the feed line, into the antenna, and it's going to be converted into electromagnetic waves. And all that power is going to be going out. Okay. In amateur work, all of these new modern antenna tuners will give you a 1-to-1. You push the button, you'll get a 1-to-1, or it won't work at all. In amateur work, a 2-to-1 SWR is considered satisfactory. Now, what it actually means is that what it's comparing is the power that's going out and the power that's going back. Okay, let's do the antenna again. So here you have your dipole antenna and your feed line. So the power is coming from here and it's going to go out. So how would we draw this? Is this I don't know, something like that. And the wave is being supported by the antenna, and the maximum power is going out, and you're going to get a 1-to-1 ratio. So it's measured in terms of voltages. So it's the voltage that's going out versus the voltage coming back. Now, if something is coming back, if some voltage power is coming back, then you're going to create what's called standing waves. So when it hits here, if it didn't go out into the air, then it's got to come back. And it's going to come back on that line. So what it's going to do is it's going to come back like, it's going to be the reverse of that. It's going to come back like this. Okay? Now that's going to be a standing wave, which is what you don't want. Okay? Usually they come back in the whole loop patterns. Okay? A standing wave, and that's considered a node. Anybody that's played a guitar, they know what standing waves are and nodes and everything. You don't have to know that for this, but what the standing wave represents is power that's coming back on your antenna. It's not going into the air. It's coming back because the match is not good. The antenna, the resonance is not good. And if the power comes back, it goes back into your feed line, and it goes back into your finals of your transmitter, and it will start heating your finals, and it can damage the radio. Okay? Now, most modern radios have devices on them that when the SWR gets high and they start heating the finals, they will start shutting down. They have heat devices on them that are going to protect the finals of your radio. Okay? So, here we have, and I'll pass this around too. Did it get all my junk back? Oh, I got all my junk back. Okay, I'll pass this one around. This is a SWR, it's a Daiwa power meter, says cross needle meter. And you'll see there's two needles here, and there's forward and reflected. Okay, you want everything to be forward as much as possible. If you get reflected, the other needle will come up and it'll read your SWR. Okay, it'll tell you what the SWR is. If the SWR is 2 to 1, okay, that's fine. We can operate at 2 to 1. If it starts getting 3 or 4, it's dicey. You know, if it's infinity, something's wrong with the antenna. It's probably on the ground. Okay, so pass that around. And that's a good type of SWR meter. But in your rig, the SWR meter is already built in. Any new radio you buy, not on the Baofangs, but it's built in. Dwayne.
I was going to say, so if it's coming back like that in a link,
Yes.
or in infinity, does that mean that a short circuit has occurred?
No, it doesn't. It doesn't mean that. It means that it's not a resident antenna, and more power is coming back than you really want in it, in the back in the antenna and in the feed line back to the. Now, as I say, a modern antenna tuner will tune it so you'll get a 1-to-1, even though the antenna itself would probably get you a 5-to-1, right? If you tested the antenna itself. But the modern antenna tuner will make it appear as it's a 1-to-1. The problem with that is it'll work, but you're getting less power actually radiated into the sky. That's the problem. Okay? Yeah, now this cable that comes with this, it doesn't do anything except light. There's a light in there and it'll light it up. That's all the power this power is for on that machine. Okay, so very important that you understand SWR. It's a measure of how effectively your transmission line, antenna, and transmitter are working. Right? You want a 1-to-1. You got if you got an antenna tuner, modern antenna tuner will probably get you a 1-to-1. You do not want high SWR. Now that's what happens on these little dinky radios. They can get high SWR and blow out. I'll pass around these two. See, because there's no meter on these little radios. Now take a look at these two antennas. And they're supposed to be identical. But if you see them, you'll see there's one element here, and then a bigger element here. And you'll see there's this bottom element is up here. Okay? This antenna is wrong for that radio. It has the right number on it, but it's wrong. And it'll make the SWR high. If the SWR is high, it's going to start heating up the transmitter. It's also going to be squeaking on the repeater. It was making all kinds of squeaking noises. And they're very bad audio. That's what happens. If I kept using that antenna, possibility I could blow that radio. Also, these connections are so dinky that if that center conductor gets bent or moved, your SWR can go up and you got trouble. Okay? So I'll pass those two around. You could compare them. Okay.
So seeing as how they're, to me anyways, as a noob, they look almost identical.
They do.
Yeah. So what makes the one less higher number than the other one? Like,
Okay.
what's
The length, there's two lengths in there, and one of the lengths is wrong for that radio. And the number on it is correct, but it's the wrong antenna. And when I changed the antenna, all the problems that I was having with the radio went. Yeah, and you should check your number. Oh, yours is a little shorter, yeah.
Well, I changed to my short one.
Yeah. So it's so it goes back to length. Eh? The length is wrong, so the SWR is going to be wrong, and etc.
I'm wrapping my thick head around this. To me, it seems like they're almost the same length, like physically the same length.
Yeah, they look, but if you look, you'll see there's one element on the bottom. When you get it, take a look, you'll see one element is longer and one element is short. There's two elements in there because that works 440 and 2 meters. And there's
even if it's like a small little part of the antenna that's like, say, that big, can offset the entire system.
oh yeah, sure, has to be the right length.
Oh, okay.
Okay, we're running out of time here, guys. So I want to try and finish this, wrap this up. Okay. Okay. Let's look at where we were before, just to show you how this works. Okay. We're going to talk about the 80 meter band. So here we have 3.6 megahertz. 3.754 megahertz, 3.40 and 3.5 megahertz. Okay, so we're going to cut the band. We're going to cut the antenna for 3.6 megahertz. Okay, and we get a bandwidth of 300 kilohertz. Okay, so bandwidth is giving us this. Okay, so we don't have to do anything. On the 80 meter band, we cut the antenna there. That's the resonant frequency. But the dipole antenna will give you 300 kilohertz bandwidth. So we get here to here, no problem, right? It's going to work. The SWR is going to be in this range. It's going to be 2 to 1 without an antenna tuner. It's going to be 2 to 1 here. See, you got all those frequencies that you can use, but here you're not going to be able to use it. Okay, so how do you solve the problem? So you want it because you want to use this part of the band as well, especially me, because that's where CW is. You just use your antenna tuner, right? For this part, use your antenna tuner. For this part, use your antenna tuner. Now you got the whole band. Okay, you've covered the whole band. Part of it was just the bandwidth of the antenna itself, 300 kilohertz, and the rest you got through your antenna tuner. But on these parts, your antenna is going to be best on these frequencies. It's going to be really good on that frequency, but it's going to be best on these frequencies. On here, the antenna tuner will tune it, but you're not going to get the maximum power out of it. Okay, it'll work, but you're not going to get maximum power out. So if you're a real nut about CW, then you would cut it. You'd cut your antenna here, so you get maximum power out there. Okay, so that's how it works. Okay, the 5/8 reflector. They have that on in the test. They spend 3 pages on the 5/8 reflector for 2 meters. Okay, all you've got to know about the 5/8 reflector, it has a lower angle of radiation. That's the only thing you have to know. Those 3 pages are a waste of time. That's all they got to tell you. Lower angle of radiation, which means you're going to get out farther. Okay, there is an antenna called the G5RV. And I'd like to, unfortunately, I didn't make copies of this, but you're going to have it at home. Okay, the G5RV antenna. This is why you don't need to build all those other antennas. You just build this one. Okay. All it is, it comes in various lengths, but you put 51 feet here, 51 feet here, and sorry for the people who want metric. And the standard one, the standard antenna, has 28.5 feet of twin lead. This is called the matching section. This is the standard G5 RV. That's the call sign of the guy who made this antenna. 28.5 feet of twin lead, right? And then you take the twin lead and you bring it to your coax cable. And you can put 50 to 100 feet. I have 100 feet on mine of coax cable on there. Okay, this will do just about every band. And with an antenna tuner, it'll do everything. The only thing is this piece of twin lead has to come straight down, and it cannot touch any metal objects. So you might have to make a standoff insulator out of plastic to keep it away from soffit and other things. But this antenna will work. There's a shortened version of it, a junior version of it, where the whole thing, the first one will cover 80 to 10. There's another one that this whole piece is 51 feet. This is the junior one. Now most people can do this, can get this in their yard. And 51 feet, if twin lead coming down, all you need is 14.3 feet of twin lead coming down, and then your coax. Remember, if your coax is going to be up in the air, then you're going to have to tape it. You know, that connector that you're going to put on there, you're going to tape it. Make sure that no water gets in there. This will do the 40-meter band and everything up. Okay? And in only 51 feet. Most people have that in their backyard. Okay? So this is the kind of antenna to build. If, you know, I could have given you this. If you've got it at home, I've sent this. It gives you the three versions: the regular, the long, and the junior. And all of this is not on the test, by the way. The junior antenna, which you can build yourself. Very, very easy. Covers all the bands. You don't need traps. You don't need inverted V's. You don't need anything else. This will work. Okay, this antenna, I'm going to give you, if you want to build this antenna, this one right here. I'll give some papers here and some papers there. You can build this little Yagi antenna out of a tape measure.
What bands does the Yagi transmit?
2 meters.
Meters?
Yeah, 2 meters. I don't think it does 440. It does 2 meters. And the guys were building them to talk to the space station. Okay, I went through the last part quickly. We're at 9 o'clock. Are there any questions? Stretch it out.
For the G5 RV, you could coil it, right? Like we spoke about coiling it?
You could, yes, you could.
Like if your yard wasn't big enough and you wanted to...
Well,
make
51
scale
feet.
one?
51 feet. Most people are going to have that.
No, if you were doing the 102.
Yeah, you could coil.
And now, your twin line...
Your twin lead.
leads, is that vertical? Are those vertical?
Yeah, this matching section has to come straight down,
Straight down, like you said.
and it can't touch any metal. It's got to be away. And people say you need a ballon here. You don't need a ballon. You could put in a 1-to-1 ballon if you wanted. You could put in a choke if you wanted here. You could make a choke here if you're having problems. But I don't have a choke on mine, but I do have a 1-to-1 ballon there. But there's a guy in town that makes them, and he just puts the twin lead straight into the coax, but he makes sure it's waterproof. And that antenna will do everything. It's not on the test, by the way. Definitely not on the test. They've got all those ancient antennas on the test, but not the one that everybody uses.
That would do 2 meters?
It won't do 2 meters, no.
So it doesn't do everything.
Well, let's see. Okay, it does all HF. It does all HF bands.
Hey Bruce, but for them, what about for that radio? What about even a J-pole? For their...
Yes, we gave you the J-pole antenna last time, the diagram of the J-pole. I think Tony gave you that. So you make that out of copper pipe, and he give you all the dimensions to make it, and that works. And Brent said he got the space station when it was directly overhead with the J-pole.
Same thing I've done, same with
Yeah, and he didn't worry about Doppler effect. With this, if you're picking up the space station and it's on the horizon, you're going to have to worry about Doppler effect, because the station is going to be a lot higher in frequency when it's on the horizon there, and a lot lower when it's over there. And you got to somehow adjust, and these radios are not the easiest thing to adjust the frequency. Okay, any more questions?
The J-pole is a full wave antenna?
Now that's a good question.
I think it's a 5/8. I think. Don't quote me on that.
Okay, we think it's a 5/8. I'm not sure.
Like, if you were to draw it schematically, would it look similar to your dipole look like?
It looks like this, right? And
Just like, I meant schematically, not like literally.
yeah, and it's got a stub on it like that, and then you connect your cable across here, and the distances are critical. This distance is what tunes it, eh? And the nice thing about this is that can go right on a metal post, and you see it's a short to ground for DC, right? The DC go directly to ground. Well, that's nice, because if it got a lightning hit, it's going to take it right to ground. But for RF, the RF is going to stay up in this part. RF is not going to be grounded. That's what that little stub does. And this has to be adjusted to get the 50 ohms.
That's exactly what I'm using right now. I have actually a dual band J-pole, and it works really well.
Yeah, oh, they work tremendously. And you will see some of this type of antenna. There are some commercial operations that even use this type of antenna. You'll see around town. Radio amateurs always look at antennas. I'm getting a high sign that we got to quit, so unless there's a question or anything, I got to pull the plug. No questions? Nothing? Have a good evening. Return your